We have a question from conic sections here. We'll start by drawing our curve. So we have a nice parabola. Y square equals to 8x. We are given a point C1, which is minus 4 comma 0, and we are given that the points where the tangents to the parabola from this point meet the parabola are A1 and B1. So we have a nice little symmetric thing going over here. Just by finding the coordinates of A1, we will know the coordinates of B1 as well. Let's say the tangents are y minus 0 equals to m times x plus 4. Which is y equals to m x plus 4. We solve this with y square equals to 8x. We need that we have only one solution for y. So y equals to m x is y square by 8 plus 4, which is equals to my square, which is my square minus 8y plus 32m equals 0. So for this to have only one solution, we need that d equals to 0, which is b square, that is minus 8 square 64 minus 4a c. C is 32m, a is m, which gives us m square equals to 64 upon 4 into 32 half. That gives us m equals to plus minus 1 by root 2. So m equals to 1 by root 2 corresponds to this line, which gives us a, and the other corresponds to the a1, and another corresponds to the line which gives us b1. Let's take m equals to 1 by root 2 and find a1. So we have y square equals to 8x equals to x plus 4 square by 2. That gives us x plus 4 square, which is x square plus 8x 16. This is x square minus 8x plus 16. This is x minus 4 square. This gives us x equals to 4. And this is expected because this is a tangent. We should get only one solution for x. So a1 becomes 4 comma y square is under root 8x, which is under root 8 into 4 under root 32, which is 4 root 2. By symmetry, we can say that b1 is 4 comma minus 4 root 2. Now let's move to the options. A is the length of line segment OA1, which is origin, and A1 is 4 root 3, which is correct. Under root A, the distance of A1 from origin is 4 minus 0 squared plus 4 root 2, which is under root 16 plus 32, which is equals to root 48, 4 root 3. So option A is correct. The B option is length of line segment A1 B1 is 16. No, it is 4 root 2 minus 4 root 2, which is 8 root 2. Now we need to find the orthocenter of triangle A1 B1 C1. To find the orthocenter, we need to find the point of intersection of the altitudes from each vertex on the opposite side. So the x-axis is the perpendicular from c1 to a1 b1, so the orthocenter must lie on this line. What we'll do is we'll simply solve one of the perpendiculars, say the perpendicular from a1 to b1 c1 with x-axis. So the slope of line b1 c1 was minus 1 by root 2. So the slope of line perpendicular to it from a1 would be root 2. So that line's equation will become y minus 4 root 2 m times x minus x1. We have to solve this with y equals to 0, which gives us minus 4 root 2 equals to root 2 times, which gives us x minus 4 equals to 4 minus 4, x equals to 0. So C option is correct, D option is not.